Hey everyone, my name is Adajian. I'm a developer at Expedia Group, and I'm super excited to be here today to talk about schema-first and code-first, which are approaches to GraphQL, or approaches to GraphQL implementation. I know we have a talk tomorrow with the topic of code-first. We've had a couple talks in the past, or at least GraphQL-Conf 2023 about this topic. So super eager to get involved in the discussion. And I don't really think it should be a debate, about which one is better. I think, we can use the best parts of both, and that's kind of what I'm going to talk about today. And in the process, kind of go through how we at Expedia Group went from fully code first to maybe a little bit of both, and highlight the kind of benefits of each approach. First, a little bit about myself. I've been at Expedia Group for 4 years now, which is about how long I've been doing GraphQL development. I build experiences for lodging shopping, so that's hotels and vacation rentals. And I'm super passionate about developer experience and open source software. And then a little context about how we use GraphQL at Expedia Group. We power a ton of brands. It's not just Expedia. We have all kinds of different legacy brands that the company has acquired over the years. But the big three are Expedia, Vrbo, and Hotels.com. And we have a federated supergraph with a lot of subgraphs. We have 70 GraphQL services. And among those services, we have 1,000 or more contributors. And so, we have to think about scale at all times. And that's what makes sort of the schema change process super important to think of, because we have to embrace change, and we're changing things a lot. So it's interesting to think about how we should and shouldn't do things when we're talking about schema changes. So for those of you who don't already know, schema first and code first, like I said, are approaches to GraphQL implementation, but what are they? So when I say schema first, I'm just talking about designing first and implementing later, but specifically maintaining and writing the SDL, the schema definition language, separately from the resolver code. I think this was the initial approach to GraphQL before things like code first came along, where the implementation is the design. You're kind of doing it all at once. And the way that works is you write your resolver code, you use some sort of tooling to generate your SDL, and then you publish it, and you're good to go. So that's what I mean by these two terms. So how are they different? The advantages to schema first is the sort of designing things first helps you think about what you're doing before you do it. And schema first specifically is more inclusive for schema design. Not just backend engineers or the people implementing the schema have to or can review it. Everybody can, because SDL is a very universal language. And it's also easier to ensure that we're designing the schema well and with best practices. Again, because we're using that SDL. But with code first, the main highlights is that you're always going to have your schema in sync with implementation. You don't really have to think about, oh, well, what if I implement something that's invalid or doesn't align with the graph? And it's also lower complexity. It's easier to do it when you just have to do one thing. You don't have to maintain two different, ideas of things, or in this case, SDL and your backend language. But it is kind of a trade-off, which we found. If you do schema first, like I said, you need to know, if you do code first, you need to know the backend language to design the schema, because that's how you create the schema, is by writing code. And it's also harder to ensure that you're doing good upfront design in a backend language. And then conversely, with schema first is subject to divergence from implementation, like I talked about, and it's higher complexity. You have to manage more things than one. So my team thought this didn't have to be the case. We wanted to have our cake and eat it too, so to speak, and we wanted to see if we could have all the pros and none of the cons, and kind of use each approach to its advantage. So that's going to be our goal today, is see if we can get all the benefits of both of these with none of the downsides. So again, that's the schema first benefits of everyone participating in schema design and making the schema easy to enforce best practices, things like that. And also with the code first advantages of our schema is always in sync with the implementation and making things easy. So if we consider these as sort of milestones, the first one we're going to talk about is inclusivity in schema design, getting everybody in the same room to look at schema. So why do we want to do that? The reason is schema design is pretty hard. And when you have to think about native apps, or at least we do, you have to think about old app versions and people not upgrading their apps. And you can't delete schema, unfortunately. You can't really make breaking changes. Something we're working on, but for the time being, we have to think about them. And as a result, we have to think about upfront design is way more important than we thought. And you have to be more flexible because maybe a type you create today, you might be forced to use 2 years later. And so hopefully, hopefully you thought it through. So I talk about getting everyone in a room. So who are these people? So obviously you want the backend engineers there, but you also want the front-end engineers, the web, iOS, Android, what have you, because they're ultimately the consumers of the API, and so they should definitely be in the room, so to speak, talking about schema changes that you want to make. And then also designers and product managers. They're also on our teams helping us build cool experiences, and they're going to have valuable input as well. And we have the ability to do this because SDL is a universal language. It was built that way. You don't have to know a backend language or even really be a developer to understand it. So, this all sounds nice, but when you use a code-first solution like we do, it becomes a little bit trickier. So at Expedia Group, we use GraphQL Kotlin, which as an open source library we created. Basically makes it super easy to spin up a GraphQL service using Kotlin. So the key feature of this library is that it takes your manually defined Kotlin in your GraphQL service and generates SDL output that can get published or uploaded and published to your graph. So how do we use this code-first solution but also take advantage of this universal SDL language? So we decided, let's do schema reviews. I know a lot of you probably do schema reviews. It's a great way to ensure good design. As a first iteration, we just said, well, we could just use markdown files. And also, if you need to show the specifics of the type change you're making, you can put screenshots of the GraphQL playground. So this is fine, but it's not using SDL, like the actual language of it. We're just using screenshots. It's kind of more like documentational. We have these templates that people were using. So it was a start, but it definitely was not the finished product. But at least we got to review schema changes a lot easier. So for those of you in the back, sorry about the room being a little bit too small, but on the left we have Kotlin, a Kotlin schema review, where we have data classes and Kotlin types, and on the right we have SDL. So we thought at least it was better to review the change on the right in SDL than it was on the left with Kotlin, especially when we're still in the design phase. We're not actually implementing yet. So now that we have everyone in the room reviewing our schema, how do we ensure that we're designing it the way we want to, or that it's good? So when I say good, what does that mean? What is good schema design? I'm not going to get into specifics of what I think are best practices or how we do it, but what I do know is that the customer is always right. Our consumers are going to tell us as backend engineers what good schema design is. So again, we have the three consumers, or at least the three clients, but those developers are going to know how we should design it because ultimately, at the end of the day, they're doing that. And as And then, so we're going to continue to do the schema reviews, but now let's actually use SDL. So, we implemented this GraphQL monorepo where we have SDL files. You can see this would be an example of a schema change that we might make. And with this monorepo, we found it useful to pull in some of the guilds tooling, like GraphQL tools, GraphQL inspector. These were much better than the markdown reviews we were doing because they could tell us really early on if we were going to make a breaking change by accident. Or even, it has cool features like it tells you that this could be a dangerous change or things like that. And furthermore, you can also do schema linting. So shout out GraphQL ESLint. It's an awesome tool, also by the guild. And the repo tooling that we kind of set up was already using the JavaScript ecosystem, so it was a natural choice. But yeah, this schema linting is super powerful because, like any code base you might want to run a linter over, it can automate some of these things that might get caught in reviews so that we never miss them. And I'm going to give an example of a lint rule that we created as a demonstration of how this can be super powerful. So if we have this type foo and a field bar with this type of list with nullable elements, so in this case it's a nullable list of nullable strings. When we get to the client implementation, the client developers, and this is a React example by the way, the client developer has to filter the list by not null, so to make sure that when it maps over the list, nothing is null. Because unless you really want to handle the null case, which we've never seen before, we're going to do this. So it just kind of adds that extra step, extra work for the client developer to do. So we thought would be good, and this is also something that would come up in schema reviews. Let's make the elements not nullable. So that's kind of what we use the lint rule for, is to enforce that the elements are not nullable. And if you look on the right, the client implementation is a lot simpler. We have the same list being mapped over, but now we don't have to filter out the null elements. So we have this new schema review process in place. It's working really well, but is this enough? At the end of the day, it's still just documentation. We might have all this cool tooling and STL, but it's not actually driving the real executable schema that we publish. And as a result, we found that even with doing these schema reviews, we still had to kind of manually copy and paste schema to get started, from the real graph, and people would forget to update this, just like we all forget to update documentation, and it would diverge from the published graph. And when we're reviewing schema, we want it to be the right thing. Otherwise, we're kind of wasting our time. Another thing we found is we would do the schema review process, review one thing in STL, but then for some reason we would decide to implement something totally different once we got to writing the Kotlin code. And this wasn't ideal because we should be thinking about the schema when we think about the schema, not when we implement it. So that was kind of a problem. And then the other thing we found was we would sometimes make typos or mess up the nullability or other kind of human error things once we went to implement it. So this was something that would totally waste time, because if we wanted something to be null, and then or nullable I should say, and then we went to implement it, it was not nullable, we'd have to kind of realize our mistake way too late, and we'd have to go back. Hopefully clients weren't querying those fields yet. So this is kind of a pain as well. So the conclusion we drew is schema reviews are nice to have, but ultimately our code-first solution, in our case GraphQL Kotlin, is going to be the source of truth. So we wanted a way to make the schema reviews really matter and not just be kind of niceties. So that brings us to our third milestone, which is we want our schema to always be in sync with implementation. So again, we have our code-first solution, GraphQL Kotlin, translating that manual Kotlin into generated STL. But again, in order to get that Kotlin in the first place, now that we have this schema review process, we had to take our manual STL being reviewed and approved, and then manually translate that into Kotlin data classes for the most part that would then get translated to STL. But as I pointed out earlier, this led to a bunch of pain points. We didn't like it. So we leveraged GraphQL-Codegen, which is an awesome tool as well by the Guild, and wrote a plugin for it, and we called it GraphQL Kotlin-Codegen. And we open sourced that as well. We figured if GraphQL Kotlin was open source, why not this tool? And what that can do is take your manual STL, might be from a schema review, generate the Kotlin that GraphQL Kotlin expects, so then we can finally generate the executable schema. So before I dive into the tool itself, I wanted to give you guys a sense of what the schema change process looked like before and after. So before, we were reviewing the schema in STL, in that GraphQL monorepo, manually translating it to Kotlin. Then we'd have to review that PR in Kotlin that was effectively just the same thing again. And then finally, GraphQL Kotlin can take over and we can publish the schema. So a lot of manual steps there. But the new process kind of simplifies it. Instead of manually translating the STL, we automatically generate the Kotlin. And we publish the Kotlin into internal libraries and then the only step we have to do on our GraphQL service is upgrade the library version. And as a result, GraphQL Kotlin can take that generated Kotlin and do the same thing that it was doing before. So a lot more automated, makes everyone's lives easier. All those pain points are gone that I was mentioning earlier. So now just a couple features to highlight about the Codegen tool. So, a couple challenges where we wanted to make sure it was generating everything that it could, that GraphQL Kotlin could process. So one of those things is STL descriptions or GraphQL descriptions and deprecation annotations. So, GraphQL Kotlin has this support. Basically, we used to write that GraphQL description, deprecated, et cetera, and that would generate those descriptions, but now we can do the other way around. For input and output types, there's kind of a special annotation in GraphQL Kotlin that ensures that your application or your GraphQL service is specifically using input and output types in the right places. So if you try to use an input in basically the resolver for a query, it's going to yell at you. So we wanted to make sure to also generate those things. For enums, it's pretty straightforward, just generating an enum class with all the members. But we found it useful to generate this helper function called findByName, which we found very popular in our code bases. And now we no longer have to define that as an extension function. It's just already there. And sorry, that helper function basically lets you pass in a string, and it will pluck out the value that matches that name. Unions are kind of interesting because Kotlin doesn't have native support for union types. It's not really a thing. So we kind of have to work around that. But GraphQL Kotlin already supports a couple different ways to define union types, and we chose the one that's a little bit more type safe. You basically have what we call a marker interface. So in the union type, or this case, we have a union called union type. You can see it's like basically an empty interface that each of the members of the union has a corresponding data class. So that when you use the Kotlin union type, it will force you to use one of those two data classes. And then finally, directives. We use a bunch of custom directives. So it was important to maintain that functionality. So the way we did this was introduce a configuration called directive replacements to the code generation tool. And that allows us to specify which STL directive we want to replace with which Kotlin annotation. So in this case, my directive is being replaced with some annotation, and it will generate that code accordingly. But we ran into a couple problems. Even though the code generator was super cool and it did a lot of what we needed to do, we still had to work out some kinks. So the first one was about resolver functions. The actual definition of the resolver functions, or at least in our case, the top level functions, could still diverge from the schema. So it wasn't perfect. So as an example, if we have this schema with resolve my type as a top level field, and takes an input, we're going to generate the Kotlin for the return type, the my type, pretty straightforward as a data class. But when we write the source code, we are defining a top level query class and inheriting the query interface from GraphQL Kotlin. That's just what we already have to do to make sure that it knows how to resolve the field. But we write the function resolve my type, and we can import the my type data class, and that's all generated, and that can't diverge. But this resolve my type function can diverge. There's nothing actually preventing us from changing that name. Maybe we make a typo with it. We could also change the input type or the output type, and nothing would get mad. So we wanted some way to enforce this data contract all the way through. So how we did that was with interface inheritance. So we take the same schema. We're now generating an open class and an open function on that class as effectively an interface. We're going to have a default implementation that throws an error because we want to force you to implement it, because we're not going to generate the actual implementation code, but we do want that interface there, so that in our source code we can also inherit from that interface, and you can now see that we're overriding this function on the interface, and now these have to be in sync. If I changed the name of that function or the input or anything, it's not going to compile. So that lets us ensure end-to-end consistency with going from the initial schema we define all the way to our source code. Another problem we found also with resolver functions is that they might overfetch. And this was kind of a performance concern that we found. So to demonstrate that, take the same schema and then now consider this client query. We're only going to request foo as the field. We're not going to request bar. Still generating that same data class. And then in our source code, when we resolve the top level field, we're going to construct the data class, and foo and bar are both going to have expensive calls. Maybe we're calling a database for each one, but they're expensive. And if you only, we all know GraphQL, one of the big benefits is you only request, or you only get back what you asked for. We also would expect the server to only do the work that it needs to do. And in this case, the way that GraphQL Kotlin and the underlying GraphQL Java library work is that when you request a field and you resolve it from using a data class, it's going to construct that entire data class. And that causes both of these expensive calls, expensive methods to be called, which we don't want. We want it to only call the one that we request. So that was kind of a problem. And again, we couldn't really control this because we just had a generated data class, and we're using that to resolve the query. So how we got around this was this resolver interfaces config, which we allowed users to pass in specific type names to generate an interface instead of a data class. So here we have a open class, open functions, similar to the other example I was giving with that not implemented error. And now, if we basically build a custom class in our source code, inherit from that interface, we now have the same effect of we're forced to override each field as a function, again, independently with those expensive calls. But this time, when we request only foo, we only do the work to get foo back. We don't need to do the second expensive call for bar. So the last milestone, low complexity, we kind of get that for free. The first benefit, and it's one of my personal favorites, is we get to delete code. Who doesn't like that? So since we set this up for the first GraphQL service migrating to generated Kotlin, we're able to delete 3,000 lines of redundant code and remove dependency on 20,000 lines of shared code. Only reason I say remove dependency on is we can't technically delete it yet because other of our GraphQL services are still using it. One day we will be able to delete it. I'm confident about that. But yeah, this is a huge win because now there's less code to think about. We don't have to maintain it, review it, write it, and we can just focus on building awesome experiences. And then as a result, we can move faster. We thought, well, we have all this less code we get to delete. We don't have to review it anymore. And as a result, we were able to decrease our time to merge the schema change PRs in the GraphQL service repos by about 2 days on average. So this is way more than we thought it would decrease. So clearly, it wasn't even just about the code. It was about the overall complexity of it all. And some things that I mentioned before about we would do one thing and say another in terms of going from the schema review to the implementation, that often delayed the whole process because if we disagreed on something but we didn't catch till the end of the schema change process, we'd have to kind of start it all over again. So this was kind of eliminating any chance of that happening. So we were super excited to see that. So to recap, our goal was to get all the benefits of both approaches with none of the downsides. Everyone's now participating in schema design. We're using SDL to review things, and we don't need to know backend languages. The more people that build the schema, the better. That's what we found, and getting more perspectives and viewpoints in the room. We're also able to ensure good schema design much more easily with things like schema linting and the GraphQL tooling, and then also getting front-end engineers more involved that can drive what it means to have good schema. And then also the code-first benefits, so schema always being in sync with implementation. We're taking that initial SDL we're reviewing and generating basically as much code as we possibly can, making sure it's in sync. And then finally, lower complexity, less code to think about and write, and we can do things a little bit faster. So wanted to just hammer home the idea that we don't need to pick between these approaches. We can pick and choose exactly what we need and use tooling to take care of the rest. So that's pretty much it. I have some QR codes for the Codegen repo on the left and then my personal GitHub on the right. Thank you all for coming to listen, and happy to answer any questions. Hopefully this works.
Oh, it might be mic too. Yeah.
Hopefully that's on.
Okay. Do you have like a backup mic that you can respond to? Or
What's that?
do you have like a backup mic? Oh, you have like.
I have a mic. Yeah.
Okay.
That's just for you.
So, okay, first of all, great. Thank you for the presentation. But I have like a question.
Yeah.
So, okay, let's just say, like, so my company right now is sort of like we're doing like the hybrid approach where, you know, there's like schema proposals, but it's mostly just like a code-first implementation. There is some interest around going to like a schema-first implementation. And I guess like my question to you is, what happens if someone's like SDO gets approved and like, you know, the Codegen happens? What happens like if they change their mind like about something because of like a technical decision made by that team of that owner of that subgraph? Let's just say like they end up not wanting to implement like this new field, or they don't want to end up like implementing like this query.
Yeah, it's a good question. So I guess my first question to you would be, was that backend engineer that has all these qualms about it in the room for the schema design?
Yes.
You know what I mean?
Yes.
But, okay, so you're talking about just, we didn't think about this earlier and we want to go back?
Yeah, because sometimes like implementations are not like completely thought out.
Sure. Yeah, so I would say it's really no different than the true code-first approach, because you could still maybe say that in the beginning. And I would imagine if you're doing some kind of schema-first process, you might have seen this already happen, even if you're not doing like full code generation. But I guess, at least in our case, if you publish new schema that's not being used yet, you can safely make a breaking change to get rid of it or change it. It would be more like if you realized a year later that you did something wrong, it's probably too late because clients are probably already requesting stuff. But yeah, I would say you can always change stuff if you catch it early enough.
Okay, thank you.
Yeah. I don't know if I should maybe pass the mic down. We don't have to use the mic too. That's fine. I can just repeat the questions for the recording. Yeah, go for it.
So you mentioned that the code will be auto-generated, the code like a resolver code. My question is, how do you introduce like your custom logic or your custom code, and how is that merged? Do you have like a change in the definition? So when do you do this merge or manual stuff? For example, when you were mentioning this really expensive code, so who added that function and how is that automated?
Yeah, and actually maybe I'll go back to that slide too. So the question was, I think you were talking about this one, right?
Yeah,
so the question was, I thought you were generating this code. How do you, where does the manual implementation step come in? Is that right? So again, this is the solution to the problem of we have complicated logic to resolve the fields. A lot of our implementation, and this is why I talked about the data classes versus the interfaces, we resolve it through data classes, meaning if you request one field in that type, it's going to give you everything back. So it's more like REST. We're trying to move toward individual functions to resolve individual fields. And if you have a field argument, you have to resolve it with a function. So it's really, we're talking about things that don't have inputs or don't have arguments. But yeah, we totally need to manually implement, for each field where it makes sense. And again, there's performance concerns if we don't. Like if all the data is coming from the exact same data source, maybe it's fine to just resolve everything. But if we have two different data sources or two multiple expensive calls, we need to break it out into functions. But again, that is done manually, and that's like a design decision we have to do when we implement. Yeah.
I guess just as an extension to that, in terms of is your central schema repository being used to generate the clients as well? And if so, isn't that creating a long distance between having all of these non-implemented fields and stuff?
Yeah, that's a really good question. That's something we've talked about at length is how do we get, all the client engineers are like, oh, you got this fancy code generation. Like we are using type generation on the clients, obviously, but can we generate other things like queries and fragments? We found that it's not going to be that easy because then we have to basically store all the fragments and the queries in that same repo. And it's going to be, and we actually use like fragment components where we have a query fragment that's defined like right next to the UI component. So we felt breaking that up wouldn't be a great idea for us, how we use it, because then you'd have kind of too many steps in the process. And if we wanted to like add a field to a client's fragment, it would be too unnecessary to kind of go through a review for that, like a separate review, I should say. But yeah, we have thought about it. It's an interesting thing.
I guess I didn't.
Was that not the
no,
question?
Sorry, I didn't explain it properly. Basically, in terms of a timeline, once a schema change is approved, I guess the clients are being generated, then you get all the types for the clients there. But then the backend engineer actually has to implement the logic, and that's going to take weeks potentially, and then they have unimplemented fields that clients are getting errors on, and there's no, how are you communicating that?
Right, so now I understand your question. So we actually don't publish the schema until the implementation is done, in the case of like the services schema. So the front-end engineer would need to wait for that back-end engineer to implement it before they can consume it. We did set something up where we do deploy like a test GraphQL server from this monorepo, where you can generate the type definitions, but you can't actually query anything because there's no implementation. So at least the client engineers are able to kind of get their hands dirty with mock data and use the generated types. But yeah, you do have to wait for the implementation. Yeah, in the back.
Hi, I don't know if this is already addressed and I just missed that part, but you mentioned you take a code-first approach first and wrote some Kotlin code. So why don't you just generate some SDLs out of the Kotlin code by maybe using introspection and review the generated SDL? What was the decision factor that pushed you to migrate to writing the schema by hand in the end?
Yeah, it's a good question. I think a couple reasons. So the first one is that when we generate the SDL from GraphQL Kotlin, it's basically immediately published because when we deploy the app, we have to also publish the schema at the exact same time. And the other thing is, reviewing the schema as SDL gives us access to all the tooling, checking for breaking schema changes, things like that. I guess we could do that, all under the hood if we generate everything. But yeah, I think it's the main reason would be that we have to basically how the services are set up with GraphQL Kotlin. So it's a kind of a limitation there.
Thank you.
Yeah. I think we might be at time. I don't know if there's any more questions. Cool. Thanks all so much. Appreciate it.